Hi, this is Mrs. Kidman, and in this video, we're going to be talking about the graphs of sine and cosine functions. Now, in this video, we're just going to talk about the general form of sine and cosine functions. We're going to sketch a picture of what their graph looks like. And then what we'll do is we'll go over a couple of examples where we are deciding whether or not a function is a sine or cosine graph, identifying the amplitude, period, and midline, which is something that we practiced doing in our last video, as well as determining the amplitude, period, and period when we're given an equation rather than a graph. So we're just going to practice identifying some characteristics of sine and cosine functions. But let's start by talking about sine and cosine functions. So the sine function is coming from that trig ratio of sine, and it is a type of periodic function that is typically seen as a wave function. So sine and cosine functions are often seen in a lot of applied sciences and things like that. So the sine function in its general form, as you can see, is this y equals a times the sine of bx in parentheses plus c. Now, each of those pieces means something a little bit different when it comes to our graph. So our period, or how long that pattern lasts, is going to be 2 pi divided by whatever b is. So if b is 1, then we know it's going to last 2 pi. And that 2 pi comes from the idea that that's the distance all the way around the outside of the circle. If it gets adjusted a little bit, that would be because we're moving twice as fast or we're moving slower, and that'll kind of adjust it from there. Now, our amplitude is how high it goes, and that a is going to be what affects it. Now, if that a is positive or negative, it is going to stretch or shrink how far away it comes from the x-axis. However, if a is negative, what it does is it doesn't change how far away it is, it just inflects it. So you'll kind of see what the sine function looks like, and we can talk about what the negative value would do to it. Then lastly, we have our midline, and our midline is what controls our up and down. And so that is going to come from our C at the end here. So if we want to take a look at a cosine function, or a cosine function, we want to take a look at a sine function here. What we're going to do is we are just going to graph it. So what we can do is an easy way to find this is actually using your unit circle. So you can look at the different sine values as you go around your unit circle and decide where things are going to be. So at 0, for our x value, what happens is our y value there is actually 0 on our unit circle. So sine starts here at 0, 0. Then what it does is it goes up and it comes back down. Now, you'll notice that these ones right here are actually labeled in pi over 3 and 2 pi over 3, which is fine, but it does make it a little bit silly here as we're trying to figure out where those numbers go. So what happens is that pi over 2, which is going to be right in between those, pi over 2 is actually where we're going to hit our maximum point there, and that's going to be at 1. So if you want to get two other values there, at pi over 3, we are at a half, and not at a half, we are at 3 pi over, or root 3 over 2, and we are still there on the other side. Then once we get all the way around to pi, we're back at 0. Then what happens here is between that 4 pi over 3 and that 5 pi over 3, we end up hitting that 3 pi over 2, just like we did before, and that's when we reach our minimum at -1. Now these ones are going to be at negative root 3 over 2, and then we come back up here to 2 pi. So you can see this pattern of our sine function going up, down, and back up. Now, because it is a periodic function, we know it's going to look exactly the same going the other way. So we know right here, we're going to hit our minimum. Here, we're going to hit our 0, and here we're going to hit our maximum before we come back down. So you can see this beautiful picture of what the sine function looks like. Now, some important characteristics to be aware of is that it crosses right there at the origin at 0, 0. Now, if you wanted to know what it looked like when we have a negative number in front, what happens is actually what this green value does. So it'll inflect it, meaning that instead of going up to start, it's actually going to come down. So it'll still cross the origin at the same place, but we'll actually end up getting something that looks more like this. And you can see how that's just the opposite of what we had before there. Okay, so that green one would be an inverse, or not an inverse. The green one here would be considered negative sine of x, while our blue one there is considered the sine of x. Okay, so we want to make sure that we're aware of both of those. Now, let's take a look at our cosine. Now, cosine has the exact same period, amplitude, and midline as does our sine value, which makes it really easy. So it's still going to be in comparison to 2 pi, and we're going to divide it by that b. So take note that if b is 2, that means we see our pattern twice as fast versus when it's 1/2, where we see it half as much. Okay, between 0 and 2 pi. So if we see a 2 there, b means that I'm going to see that pattern twice between 0 and 2 pi. If I see a 1/3 there, that means my pattern, I'm only going to see a third of my pattern between 0 and 2 pi. You kind of see how that goes there. Our amplitude is still going to be that absolute value of a. So if it is negative, it's going to invert it, just like we saw with that sine function, and our midline is going to be at C. Now, cosine does get shifted a little bit in comparison. If you look at your unit circle, you can find this. So at 0, we actually are at 1. Then from there, what ends up happening is we go to 0 when we're at that pi over 2, which again is going to be right in between pi over 3 and 2 pi over 3. Then at pi, we end up at -1. We end up back at 0, and we go up to 1. So you can see how this one actually looks exactly like the sine function, but it's just inverted there. Okay, so you can see how it ends up looking exactly the same. And that is the beauty of it. So it's kind of like the same function, but shifted. And so it's really interesting when it comes to writing these sine and cosine functions that it's the same function, but shifted over to the left or right. So cosine always crosses here at 1, 0. So you'll know the difference of it being a negative cosine of x because it'll have the point -1, 0 instead of +1, 0. Okay, so that's kind of your introduction to sine and cosine functions. What we're going to do next is take a look at a couple of examples of identifying whether something's a sine function or cosine function, and then some of its characteristics. Okay, so let's take a look at this first one. Is this first one a sine function or a cosine function? Well, what gives it away is sine is always going to cross at 0, 0 unless it's been shifted up or down. So unless it has a different midline. Okay, so the easiest way to think about it is on your graph, we know that it's going to look something like this. So the middle of our graph is going to cross at 0, 0. If a maximum or a minimum is what crosses on our y-axis, that's when we know it's cosine. So this very first one here is actually going to be a cosine function. Now from there, we can look at our period, our midline, and our amplitude. I'm going to do this in whatever order we would like, but we are going to start by identifying our maximum and our minimum because we know that's how we calculate our amplitude and our midline. So our maximum here is going to be 2. Our minimum is going to be at -2. So in order to calculate that amplitude, we are going to do our max minus our min and divide by 2. So in this case, we would get 2 minus -2 over 2, or 4 over 2, which equals 2. So our amplitude in this case is 2. The period is how long our pattern lasts. So if I go from the top to the other top, how long does that last? And I can see I start at 0, I go up to 4. So in this case, our period is 4. Our midline is going to be our maximum plus our minimum divided by 2. So in this case, we would get 2 plus -2 over 2, or 0 over 2, which is just 0. So I'm going to draw a dotted line there at our midline, just as a reminder. But you can kind of see how that relationship works there. Now let's take a look at our other one. So notice how it crosses in the middle. This is our max, this is our minimum. We're crossing right here. That's what makes this a sine function because of where it crosses. Now, just like we did to calculate before, we want to identify our max values and our minimum values. Now, looking at this graph, you can see that it's kind of small here. So if this is 1 and this seems like it's halfway in between, I'm going to see my maximum probably at +0.5 and my minimum is going to be at -0.5. So if I want to calculate that amplitude, I'm going to do my max minus my min divided by 2. So that would be 1/2 minus -1/2 over 2, which is going to be the same thing as 1/2. Our period is going to be how long our pattern lasts. So if I start here, I would go up, down, up, and we can see our period in this case is also 4 because we have that whole pattern. Our midline is going to be our max plus our min divided by 2. And in this case, we end up getting 1/2 plus -0.5 over 2, or 0 over 2. That was fancy. Okay, if you have any questions, don't hesitate to ask, but that is how we find those. Okay, now if I wanted to find the amplitude and period and midline of a function that looked like these, what I would do is I would base it based off of that information that we had before. So if you go back to your previous page of notes, or if you look up above, remember that when we have these general forms, we've got this y equals a times sine or cosine, whichever one you want. And then on the inside, we get that bx plus c. Now remember, our amplitude is going to be the absolute value of a. Our period is going to be 2 pi divided by b, and our midline is going to be at c. So let's go ahead and take a look at each of our equations here to figure out where those pieces are. So with this first one, our period is 2 pi over b. This would be a, this would be b. C in this case would be 0 because there isn't anything added or subtracted. So our period would be 2 pi divided by 3. And that's how long it would be. So what that means is between 0 and 2 pi, I'm going to see my pattern 3 times. So that pattern is going to be 2/3 of pi, is about how long it'll take me. My amplitude is going to be the absolute value of A, where if A is 2, that means my amplitude is 2. My midline is going to be whatever's added or subtracted. So in this case, it's going to be at 0. Now let's take a look at our other one here. This one's a little bit more complicated. So our period is always going to be 2 pi divided by B. Well, this is B, this is A, and this is C. So 2 pi divided by half. Now there's 2 ways to do this. If you remember how to multiply fractions or divide fractions, awesome. If you don't, remember you can always use your calculator. But if we do it by hand, this would be 2 pi over 1 divided by 1/2. We copy dot flip, so you get your 2 pi over 1 times 2 over 1, which ends up equaling 4 pi. So what that actually means is that we see half of our pattern between 0 and 2 pi instead of the whole pattern there. Our amplitude is going to be the absolute value of our A. So in this case, we want the absolute value of -3, which is just 3. And then lastly, our midline is going to be this last number here. So we're going to have a +4. So if you have any questions, don't hesitate to reach out. But that's kind of where our sine and cosine function is and how we can identify these same characteristics based on where those things are. Thank you for watching our video. And if you need anything, don't hesitate to reach out. Thank you.